First problem, find first unique character, LeetCode 387. Our first problem here was carefully chosen. We'll be introducing what's probably the most common data structure in solving interview problems, which is formally known as the hash table. And we will show two different but equally viable solutions to this problem. Don't just think of this as a warm-up round though. What we learned here, we're going to be applying throughout the entire course. So into our problem, find first unique character. And here's the definition. Given a string, find the first non-repeating character in it and return its index. If it doesn't exist, return -1. Here we have a string. By first unique character, we mean first from the left. So reading left to right, the two A's are not unique, but the R is unique. So that's going to be our first unique character in this string. We can extend this example and assume that our input will always be a string of some combination of characters, upper and lower case. Our output will be a number representing the index of that first unique character, unless of course there's no unique character, in which case we would return -1. Possible edge cases, although these are to be expected, might be having an empty string as an input, or having no unique characters. Finally, we'll assume our input is always a string of upper and lowercase letters, and we'll never have a funny input, for example, a number that shouldn't be there. Let's start working on our first solution by first breaking down what we know. If we think programmatically, we know each character appears a certain number of times, whether that's 0, 1, or more than 1. If a character appears once, it's unique, which fits our definition. So we have to count up all the characters to determine which ones are unique. But how do we do that? To check each character, we're going to want to move left to right through our string. And the best way to do that is with a loop. We'll have to count the appearances of each character within that loop. So each character we look at, we'll have to either create or add to an existing counter. Since we need one counter for each character, we need some kind of a data structure to keep them organized. So I'd like to introduce my good friend, the hash table, which you could say is the most basic and most useful of data structures. Now the hash table is what's known as a key value store, on which we can perform lookups in constant time. Now that's a formal definition for saying it keeps things organized and it can retrieve and store things quickly. We'll use an object for this in JavaScript or a dictionary for this in Python to represent the hash table. So here's an example. A, we have 2 of those. So our key value pair is A2. On R, we'd have 1 of those. So key is the character, value is the count of the character. Now moving from left to right through this string, we'd want to either, like we mentioned before, create a counter or add to an existing counter. So if I'm on the first A, I'd create a counter and set it to 1. The second A will identify A is already in the table and then add 1 to that 1. R, create a counter, and so on. If we continue doing this, we'll have a complete representation of all our character counts once we loop through our whole string. So we have multiple unique characters, but how do we return our first one? Unlike an array, a hash table does not keep our entries in order, so we can't loop through it expecting R to be the first unique character. That means we'll have to loop through our string again, pull each item out of the hash table, and then the first one that is unique, we can return its index. So this gives us a complete pseudocode plan. So it's at this point, if you want to try to code this yourself, go ahead and pause the video. Otherwise, we're going to continue on and dive into the code. Let's write our hash table implementation in JavaScript. We'll start by declaring a variable hash table and setting it equal to an empty object. Then we can loop through the characters in our string by using a for-of loop. This simply gives us each character in the string in the variable character on each iteration of the loop. Inside the loop, we check for the existence of a counter for each character. So if hash table key character exists, you could also do is not undefined, but it works the same checking for the existence of a counter at that key. So if that counter exists, then we can increment it by 1 with the plus plus increment syntax, which is changing the value of the number at this key. If that's not true, well, we need an else. And in that case, we'll create the counter by setting the value of that key to 1. Now that our hash table has been built up, so to speak, we want to create our second for loop. But there's a slight problem with using a for of loop again, and that's that we don't have access to the index. So the most straightforward way to do this is to just use a standard for loop with let I equals 0, I is less than the length, incrementing I, which I'm sure you've seen before. Within the loop, I will capture char in a variable, just to be extra clear, by using its index. Check the hash table, then I'll check the hash table to see if that char value is 1. In other words, it's unique. If so, I'll return the index. Finally, our fall through case. If this condition was never hit, then we didn't return anything yet. So we do need to return -1 at the bottom. Now on to our big O, time complexity. A good place to start when you're considering your time complexity is a loop, because that will take at least n time, where n is the number of items you're looping over. Now in this case, n would be the number of characters on our input, because we are checking each character at least once. Now we do have 2 loops, so how do we reconcile that? Well, one happens after the other, so we can represent this as n and then another n, so n plus n, which reduces down to 2n, which reduces down to just n. Remember, you drop the constant, so we have linear time. Within our loops, we're doing a lot of hash table operations, storing and retrieving, but these are all constant time. What about space complexity? This is actually a tricky one, because it's easy to assume that it must be O of n2. N characters, if they're all unique, you would have n places in the hash table. But this is not actually the case. Think about it for a second. The maximum number of keys we could have is all the letters in the alphabet, so 32, plus all the uppercase letters, 64 in total. That is the maximum number of keys we could ever have. So our space complexity is O of 64, which reduces all the way down to constant space O of 1. This hash table solution is pretty nice, and it teaches us about one of the many uses of a hash table, and we'll certainly see the hash table again. However, there is an alternative, much cleaner solution if we're coding this in JavaScript. So JavaScript has a built-in string method, which you call with the dot notation, called index of. This will perform a find operation on our string and return the index of a character. So kind of what we're already trying to do. So if I do index of A and my name, it'll give me the first A. Now there's a less commonly known method called last index of, which gives me, you guessed it, the last A. So if I just compare these two indices, in other words, index of and last index of, and they're equal, then I know this is a unique character because the first is the same as the last. So let's dive right into the code for this solution. So it might blow your mind how simple this one actually is compared to the other one. We'll first write a standard for loop going from I to 1 before the length of the string. And then inside that for loop, we simply capture the character in a variable. And we do just one check, which is string index of character triple equals string last index of character. So we are checking equality between the first and the last index. If this is equal, then we'll return I, and our fall through is still -1 if there's no unique character. How about the time complexity for this one then? Well, each of these operations is O of n, because we scan the whole string with a find operation to look for that character. These two index operations, kind of like our last problem, are in sequence, so they're going to be n plus n, or 2n. However, these are inside a loop, so this is going to run for every single iteration of the loop, and when these operations are nested inside of a loop, we have to multiply it instead of add it. So the overall complexity of this problem could be as bad as 2n times n. And multiplying two n's, we get n squared, or quadratic time. If we look at the space complexity, well, we're not using any data structures to store intermediate variables. So we are using O of 1 space, constant space. Okay, that is our first string problem done. Even if this first one was hard for you, try to focus on exposure to these problems instead of mastery. It's more about your problem-solving process and ability to identify patterns rather than memorizing the exact right solutions. And that goes for all these problems. That being said, the hash table data structure is definitely something you want to master before going into an interview. Not to worry though, we'll get plenty more practice with it in the upcoming problems.